Hello Linux lovers, my name's Wimpy, welcome to my world. If you're watching this after the fact on YouTube, this was originally streamed live, there it is. Hello Paul, how you doing? Live on twitch.tv/Wimpy's World. So if you would like to join in with the rest of the community and get involved in these projects and find out what's going on, I stream every Monday, Wednesday and Friday. Give us a follow at twitch.tv/Wimpy's World. And if you're watching this on YouTube, then, you know, smash that like button and get subscribed and all of those good things as well. Good morning everyone, how are we all doing today? I've got my tea. It's a good day for a cup of tea. Oh, hello, Takov. I didn't think you were going to be able to make it. How nice that you're here. Aha, and Chelsea Cucumber indeed. Right, so today is going to be more work on Retro Home. That is a retro gaming emulation operating system for the Raspberry Pi, built using Ubuntu 22.04. We did the initial migration to 22.04 on Monday. On Wednesday, we fixed some of the fallout from that transition. And today, I'm going to go over a few more of the improvements that have happened since Wednesday in order to sort of stabilize that move to 22.04. And then we're going to get into writing some drivers, or at least re-implementing some drivers for the first case. The whole point of this project is it'll have a generic Raspberry Pi image. Hello, good morning. Hello, Popey. How you doing? It'll have a generic Raspberry Pi image, but there's a whole bunch of interesting cases. Here's just one such example. This one here. And they all have like, you know, buttons and things to power them on and off and reset. And some of them have fan controllers, all sorts of bits and pieces. And so we're going to create bespoke images for each of these devices. So it's super easy to get an image and stick it on, and you know it's just going to work and all the features will be enabled. So I have some a dev machine here. This uses the DeskPi Pro case. And like some of the cases, so that's a more traditional case. It's actually really good. But what we're going to do is enable that case. That has a fan controller. It has a safe shutdown power off for the embedded microcontroller. And it looks like it's got an infrared controller as well. So we'll try and get all of that working. But before we do that, I'm going to explain everything that got better with Retro Home basically last night. Hello Zeb, welcome back, good to see you again. So Takov says he's leaving in a moment, so okay, well then maybe you can catch up with the VOD. So Takov has been doing a lot of the background research on the case drivers that we're going to need to implement, and thinking about how we can do that in a cohesive way. So sort of a framework, if you like, for creating those drivers. And Tackle's had some great ideas about improving the way that those would work using sort of, you know, Linux APIs rather than just, you know, dodgy GPIO header drivers. Hello, King Egypt. Welcome back. There you go. So let's get into this. Let's go and look at what's improved, because there's been quite the set of improvements to Retro Home since we last looked at it, or at least since you last looked at it. Uh-oh. I can also see over here. Why on earth is something trying to put... Oh, it's Lurk, isn't it? Okay. We'll have to go and... We'll have to go and fix that. God dear me. Okay. So I was doing a build in the background and already I can tell there is a problem. So I added something and just expected it to work, and that was foolish of me, wasn't it? It's going to install the whole mail server and Apache. Oh gosh. Right, we'll have to go back and fix that in just a moment. That will be, fortunately that's in a late stage, so it'll be quick to rebuild. Right, let's go and look at some of the changes then. So, well, that's the wrong thing entirely. Let's go here. So, I thought it would be good to... Why am I seeing a change here? That's unusual. Okay. Anyway, so we've added here the DeskPi Pro as a case type, and we'll get back to that in a moment. But I think the big improvements, nothing significant in the way things are built here. That's all pretty stable and well understood now, but there's been some big changes here. So the piece that brings up Ludo itself, the thing we're using as our front end for our emulation, we've really minimized what gets installed here. So essentially we're installing a very minimal Xorg server with only the mode setting drivers, because that's the only drivers that the Raspberry Pi uses, or at least uses at the moment. I wonder if we might need to use the frame buffer driver for some of the handheld devices in the future, but for what we're working on at the moment, we only need the mode setting driver. So we've shrunk down sort of how much of X gets installed. And then this library is what Ludo itself uses to render its UI. And I did have a whole big long string of additional libraries. It turns out all of those are in the suggested packages for this. So what we're doing is we're installing that package with the uncommon install suggests. So we get all of those EGL 1 and 2 and a whole bunch of other OpenGL related stuff. I've moved this up. This is something that will need some work in the future when we get to the smaller images. But this is what's required to bring up the display manager. And then there's some big changes here. So we've dropped out Fay, which is a thing for putting background images, and we've moved to XLI simply because it has fewer dependencies. So it brings the size of the image down, but gives us the same functionality. And also Conman, which is the what Ludo uses as its network manager, can support IWD, and IWD will hopefully be the future of sort of wireless connection management, replacing WPA supplicant. So IWD is intended for embedded devices, and it's intended to be low resource, so ideal for what we're making here, especially when you think about eventually we're going to be implementing handheld devices. So this is something new for me to learn, and it worked brilliantly. So other than having to specifically enable the IWD service, it works a treat. The Samba stuff is unchanged, although there is a significant change with that in just a moment. And then here I've tidied up the way that we install the various audio subsystems, the options being PipeWire and Pulse Audio, and I've now made PipeWire default. And that had a number of interesting side benefits, one of which I knew about already. So the first thing we can do by using PipeWire is here, this installs the full suite of high fidelity Bluetooth audio codecs. So that's aptX, aptX HD, AAC, LDAC, and then all of the common ones. So we get high fidelity Bluetooth audio, which is obviously an improvement. But the other surprising benefit was PipeWire seems to do a better job of detecting the HDMI audio interfaces, which is going to be the common way audio needs to be piped. I've had real difficulty with my capture setup where it wants to play out over the headphone jack or the analog audio, and therefore I can't capture it or hear it through my setup. And that was why I had a whole bunch of tweaks to sort of use the legacy ULSA driver and to force audio out of both HDMI and analog audio at a firmware level, and that introduces audio latency. So PipeWire seems to fix that problem, at least for me and the testing that I've done, which is terrific. It also means I could remove all of those legacy ULSA hacks, and that in turn means that I can implement the full KMS driver, which is also fantastic because that performs better for the actual game rendering and what have you. So this was a real win. Yay PipeWire. I'm very happy with my first sort of experiences with that. Nothing's changed here in terms of installing Ludo itself. This is the micro desktop environment, which has just been, curiously, installs more packages but is smaller now. I just provide English language stuff and enough to bring up, a sensible amount of the desktop environment. I've actually been having quite a lot of fun working on this bit, probably focused on that a bit too much, but it's been good fun. And then we also set up a full selection of indicators now, so you can manage Bluetooth. So we've dropped Blue Man again. That, for curious reasons, its packaging lists a whole bunch of very large icon sets, so it actually ends up being quite a many hundreds of megabytes of stuff. So by moving over to the Bluetooth support within GNOME itself and using indicator Bluetooth, we've also been able to shrink the size of the image down when we're shipping this little desktop alongside with it. I've got to a point where I don't need these sort of in air quotes dev tools to help me poke around the system, so I'm no longer installing those by default. I'll just install those manually as I need them. Nothing's right, and then this is a change. So this will come into play today. This is the first move to supporting different cases. So what I was doing in the past is the command line.txt and config.txt, which configure the kernel and the bootloader for the Raspberry Pi. I had a generic one of those, and then for each of the cases was poking additional configuration into the end. Having looked at sort of the notes that Takov has assembled, I get the impression that some of these devices are going to be very distinctive. So I think it will be easier if we have a configuration for the bootloader and a command line for the kernel, which is discrete for each case type. So that's what this does. It goes and looks at what remix we're building and injects the appropriate bootloader configuration and kernel configuration into the image. So that's our first step towards multiple case support. I don't think any of this has changed. This is all working fine. Minor change here, we just move this package into the kernel configuration because it actually drops in new dev rules and it's got more in common with the kernel than the desktop stuff, so it's better to be put here. Right, hey Luke, how you doing? I'll just catch up on chat. Right then, and Tommy Luco, hello, good morning, welcome back. How you doing today? IWD is terrific. So Tommy Luco makes this point here. Just hang on a minute. Why have I got no featured chat today? Well, that's rubbish. Just 1 minute. Let's see if we can encourage that to work, because this is going to be a massive pain if it doesn't. Oh, why does it do this? Okay, looks like featured chat's on the fritz today. So, but Tommy says IWD is awesome. Yes, it is. I really like it, and the first thing I noticed is how much quicker it is to populate the list of available wireless networks in your vicinity compared to when WPA supplicant's in use. And we have a first-time commenter who I would love to have brought up on featured chat, but apparently... Oh, here we go. It's going to work now. There we go. So, hello, Megamorph. How you doing? So, could you explain the use of nspawn? Yes, I will talk about nspawn. I will go back and explain that for you. Do they mean containers in the Docker Kates, or what concept is meant here? Okay, so what we're looking at here is a build script that builds an image for the Raspberry Pi. But what I want to do is I want to build that image on my very fast, powerful PC, not on a Raspberry Pi. So this build script runs on my PC, and this nspawn is a helper function in the script. So we'll go and have a look at that. Here it is here. And what this is this is a helper function and a wrapper for systemd nspawn, which is systemd's container manager. So what this does is it basically brings up an instance inside a container and enables me to run a command inside that container. So it does some setup and then runs whatever command I give it here. So it and it uses QEMU user static to do the syscall translation, so that although I'm on a PC, I can have foreign architecture containers and I can compile code in those containers if I wanted to, but it's enough that I can, stand up this in this case a 32-bit ARM container and operate on it iteratively to build the image. So that's what this nspawn stuff is doing. It's just a wrapper function to step inside the container and run something. It's super useful. Years ago this script was using chroot, and it was a bit unreliable, and it's been super solid since I did this. But if you're interested in container stuff, my day job is working with containers, and later today we're going to be streaming here on Twitch. It's twitch.tv/slimdevops. Everything I do at work is about container optimization and container security. You're welcome, and welcome to the stream. Thanks for stopping by. Yeah, chroots are super messy by comparison. Having to deal with all of the mounting of the, stuff, like an animal, it's horrible. So, that explains where we are with this stuff. This is all unchanged. This is where there's a big improvement. So, it is... whereabouts is it? Just about somewhere here. Here we go. So, I'm delighted to say that this is now a secure platform. So we're using Ludo, which is a front end to the libretro cores, and it's like an alternative front end to RetroArch. Now, Ludo has a way of being run, which is called Ludo OS, and that's intended to be run in that fashion for like set-top box type, an actual console use, rather than just an app on your PC or Pi. And some of the assumptions that mode makes, because the maintainer of the project has a Ludo OS image, which is based on LibreElec you can download. But the assumption is Ludo runs in the root context, and that's so it can call systemctl enable Samba, disable Samba, enable Bluetooth, disable Bluetooth, and so on through the toggles that are in the menus. So in order to just sort of lash things up, we had this mechanism where it would boot into the retro home mode and boot Ludo in Ludo OS mode, but that was running as root, and then it was a whole bunch of symlinks back into a regular user account, and it was a big fat mess. Anyway, long story short, we've now put a policy kit rule in place which enables users in the sudo group to manage system services without having to use sudo and without having to run in the root context. So now we can bring up the retro home session, which is the full screen Ludo experience with all of the management features, but it doesn't require the root context, which I'm very pleased about. We could constrain this more, but for the moment this is a huge step forward and simplifies things significantly. And now that this is working the way I intended, we can really push on, because I think enough of the bits are in place now that this is a targetable platform to do the rest of the work. So I see there was some other questions here. Let's have a look. I really could. Containers including... Yep. Yes, so YetiOps, you're absolutely correct. Systemd nspawn uses all the same container primitives that we know and love with all of the different container technologies. It's just a tool that is part of the systemd suite of utilities. For this purpose, it's very simple to use for the purpose of what I wanted to do, which was build applications quickly for ARM on mega powerful PCs. I really like it. Systemd nspawn is a really great build tool. So oh, Seb, this confuses the hell out of me. Well, I don't know about a master at work, but definitely, you know, at work or at play maybe. Right then, let's just check I've got everything here. Yeah, well, and you know, this is all part of it. You know, come for a tea and a chat. We do take a little diversion into different topics as they come up. So yeah, and you know, what happens is sometimes we work on something here and it sparks people's interest, and other people think, oh yeah, I want to work on that, and they get involved in things, which is terrific. Right then. So Tommy says, I can't call myself a programmer either. I roll my head over the keyboard and hope Hello World gets printed. Yeah, I had somebody refer to me as minimum viable programmer recently. So, yeah, you know, I can do actual programming when I want to, but for the stuff I do here, I want to do. It's like when you go skiing. You can go skiing and go down the red and black runs and really challenge yourself. Or you can go down the blue and green runs and just have a really lovely time. Just like, you know, swoosh around and enjoy the scenery. When I'm streaming, my programming level is set to blue and green. Super casual, super easy, nothing too demanding. Most of the time at least anyway. Right then. Let's get on with this. So, yeah, MVP, but no, the minimum viable programmer is what they were going for there. What's that? Black Udon. Welcome to the stream, by the way. Thanks for stopping by. So, no root context anymore, which is absolutely fab. I'm super happy about that. That enabled us to remove a whole bunch of additional cruft. I think all of this is relatively unchanging. Now, here are some changes here. This is an important change. I've been struggling with a really weird issue with my capture setup, which is now fixed. So we have this little script here, which is, in air quotes, our session for the retro home Ludo thing. Most of this is unchanged. I've just added this, which is to hide the X cursor for the mouse. That will come into play when we get to handheld devices in the future more. But I've injected this here, this HDMI refresh, just before we launch Ludo itself. And what HDMI refresh does is this. It waits. I've tried to find an elegant way to prevent this race condition, but I can't actually do it. So we just sleep for 10 seconds, which is a bit rubbish, but it's serviceable. And then we go and inspect the resolution of the display, because what happens is when Ludo brings up the display on just my Raspberry Pi 4s and just with my capture card connected, it resets the resolution to 1920 by 1200, and consequently the performance of Ludo falls through the floor, and it's abysmal. So what we do is we wait a little while, long enough for Ludo to start up and change the resolution. We then inspect the resolution, and if the resolution is now 1920 by 1200, we just jam it back to 1920 by 1080. That sets the resolution correctly, and all of the performance problems go away. So this is very much a solving my own problem, but this means it speeds up the iteration process for me, and maybe it will solve a problem for other people who, you know, might get into this at some point. But I will put more guardrails around this as we figure things out, as we tackle other devices in the future. Hello, Rich Codes, welcome back. How are you doing? It's been a while. Right then, so I'm very happy with that change. That's quality of life improvement for me. We've tweaked up the desktop environment a bit, we've simplified things, and here we go. This is where we're going to be focusing our attention a little bit. This is where we look at the various case support things that we want to implement. And this is where I've just introduced a big fat bug, so we'll go and fix that in just a second. And here is our conditional for the case that we're working on today. Here's a collection of notes. I did a little bit of reading ahead to figure out how we can get the temperature, like so. So we'll be working in here to add support for the PWM fan in the case. We'll actually try and implement it in a way where it looks at the temperature and adjusts the fan speed accordingly. We need a actual shutdown, send a signal to the microcontroller to power off the daughter board in the DeskPi to actually fully shut down the device. Because if you issue a shutdown through Linux, it will shut down the Pi and the operating system closes, but all of the power to the board is still up, so we need to shut that off. And what was the other thing? Power, and infrared, and that's where I've just broken things. So we're just going to take a look at this, because I think this is the first bug that I've encountered. Oh, Rich, you've been working on Django and Python. That's good. I'm going to be working with Python today. It's been a while for me Pythoning, so you can tell me where I'm doing it wrong. Thank you in advance. Right then, let's take a look at this then. So let's just head over to a terminal here. See, this is still going. Look at all of this stuff it installed. This is mental. Node, look at it all. It's still going. So let's just go and look at those two packages and see what their dependencies are, because we probably need to Python 3, I think it was just serial. Oops. So this has a dependency on just Python 3 and it's a module itself, so this is perfectly fine. And in fact, I know this, I know Doku, we used to work with Doku, so we don't need any of the Wix stuff. That suggests, so that won't get installed by default, so that's fine. So apt show lurk, and this is where we ran into trouble. So interestingly, why did this install, why did that install a mail server? We're going to go and have to go and find out. So why? It doesn't appear to be anything obvious there that would have done that. But something certainly, let me just see if we can, I bet we haven't got enough command history to go and find out, but look at all of this stuff. What on earth? Tracking down whatever this is. What did this? Took... It's just loads of stuff. So I'm probably just gonna have to let that finish, but look at it all. It's just installing every language imaginable. What's going on? I've seen PHP, I've seen Apache go by, it wanted a mail server at one point. It's just installing everything you could possibly imagine. So yeah, I'm gonna, the Pythoning we're going to be doing today should be pretty straightforward, Rich. I'm not expecting it to be too complicated. basically going to be reading some things off the CPU temperature and then issuing. We're using Pi serial. This is what all of this was supposed to be. Look at it, it's got node in here. What the heck? Just I'm stunned at whatever has happened here to pull in all of this stuff. So we should probably go and have a look at what did cause that. So let's just look at the recommended packages to start with. So let's look at this. I mean, none of this will have brought in anything that we don't need. It's got no recommend, so it's not that one. And some of that will get pulled in via the desktop, but we don't need it anyway, so if we install with no recommends, that's fine. Python 3 YAML. Can't imagine that's got a million dependencies. No. Okay, so let's just check that. What I'm trying to do here is just identify if there's something that's pulling in a bazillion things. It's not that either. Okay. So that should be in the minimal system, I think. So let's... What's this? I know what it is, but I wonder what it's installing. It could be that. No. No. And systemd should be in the minimal system, so I can't believe it's that's bringing in a ton of stuff. I mean, we don't need to do recommended packages there anyway. So I may just, when this is finished whirring, I may just rerun that stage of the build again without lurk in there and see if that doesn't do all of this, because this is properly mental. I mean, it's literally installing every package imaginable. So that I didn't expect that to happen, that's for sure. So let's just look here. So none of these recommended packages can be responsible. So it must be one of these that's got something. So maybe enabling infrared is not going to be something I want to do at the moment, given that this something here is pulling in all of the things. So in the build script, there was one significant thing that I changed, which is these two commands here, which is to add the dependencies that are going to be required for, well, the driver we're going to write needs Python 3 serial, and the infrared driver needs lurk. So I think that is what has been bringing in all of these packages, because nothing up here, well, everything up here was tested last night, and I knew it was working correctly. So I'm guessing that this is the most recent change, and therefore the problem. So the problem is that I can't interrupt the stages in the container. I just have to wait for it to finish. But it's kind of mental. Yeah, that's what I'm going to do, Rich. So Rich says run it without lurk is exactly what I will do in just a moment to test the theory. We will also do that as well, regardless. So that's a bit of a problem if this is going to do that, because I'm surprised that it would be lurk. I mean, how can it be? none of those are going to be responsible. Let's just check the USB. That's all fine. We know it's not going to be... Oh, is it all of Python 3? Is that the problem? It is all of Python 3. So, predepends Python minimal. Okay. That doesn't actually pull in everything imaginable. What's that? Not show. Yeah, indeed. Having a good think here, Paul. Yeah, I'm just surprised so much stuff got pulled in, and I really don't want so much stuff. So, MIME types and MIME support. Let's show which ones. So that would have been what gets pulled in. That's fine. Well, that's where SQLite came from. There's quite a lot of stuff coming in through that standard library, but we need this anyway, so this must be on the system. It must be Lurk. I can't think of it being anything else. Let's have a look. It's not going to be that. It's not going to be that. What's this? That's only got a dependency on libc. That's fine. That's going to be fine. That's fine. Well, I think we'll just can that. Let's see how we're doing. Something Raspberry Pi related on Twitch. Yes, hello. Welcome. Thank you for stopping by, Antimatter. Welcome to the stream. I'm building a... Oh my god, look at this. MySQL. How is this possible? How did all this stuff get stood up? Well, wait for that to... And then we'll burn it. We'll burn it to the ground. So I'm working on a Raspberry Pi operating system for retro gaming. It's built using Ubuntu 22.04. And so what we're going to be doing today is we uplifted it to 22.04 on Monday, did some fixes on Wednesday. And today, after I fix this bug I've just introduced to the build system, which basically seems to install every package in the Ubuntu archive, which I do not want it to do, we're going to be implementing some case drivers for the first case. So the idea is that our retro gaming OS, it will specifically target the different cases that you can put a Raspberry Pi inside for retro gaming, and we'll have drivers for the discrete features of each of the cases. And the first one I'm going to do is my dev machine, which is a DeskPi Pro. We'll do that today, get the fan, the PWM fan driver working, and the save shutdown working. I think we'll sidestep the infrared controller on the basis that that appears to be the problem that I'm fighting at the moment. Hey, Popey. Yeah, there's all sorts of stuff flying by there, Rich. I mean, you know, that dependency tree has just exploded and we need to rein it in. So that's what I'm working on, and what we have here at the moment, or what we were looking at, was this is the script that builds the Raspberry Pi images. So it runs on my PC and it builds a foreign architecture container to make the image. And if we head over here, you can find this project here on GitHub, Wimpy's World Retro Home, and this is where the build script lives, and hopefully sometime soon. So at Christmas time last year I did like the first alpha build, and there is a an image that you can put on a Raspberry Pi. But what I want to do is now get an initial alpha out for 2204 because it's massively improved. Yeah, so I'm going to have to think up a new versioning system, but my intention is no later than midway through next week we do have an image up here that people can download and start testing. Goodness me, what the heck. There we go, we can actually see what the... Just bear with me, I'm going to just pull this off screen so I can look at it up here. I want to see the full output of that to see what actually... Oh! Oh! It was not what I was just blaming. It was not Lurk at all that's responsible for that. It was actually something that I've previously tested and that appeared to be working fine. So we'll just drop that back down here. I will show you where we have identified the problem. It was all the way up here. So the troublesome command is this one. So that is what caused it to all go crazy. So I thought that this was fine. So somewhere in there, yep, oh balls indeed, Paul. Right, there we go. So let's have a look. What have we got in here? How would any of these things... Pull in all of that stuff. That's fine. That's fine. Let's just double check that shouldn't. This is the GL vendor provider. That's fine. That's also fine. This doesn't make any sense. How can it be that command that's broken it? And like I say, this definitely was not doing weird things last night. So the last part is that's fine. Doesn't have any recommended packages. That shouldn't come in a lot though. Okay. Mesa Vulkan drivers. Ah. Okay. Well, we are going to do that differently then, for the moment. I mean, none of that's a problem. That all looks sensible to me. Can't see anything in there that would not already have been installed on the system. That's all fine. So I'm now even more confused why it's that line that's causing this problem, but we can remedy this. So let's go and look. Is this actually finished doing its thing yet? It won't, will it? Because it's got to. Oh wow! Look at all of this. Look at this. Look at this random stuff. The heck? Spam assassin? Where did this all come from? I'm just going to leave that up whilst I bring up the terminal and bring this up on my own machine here. I want to double check what's going on here, because yeah, it's definitely that command that's responsible. I mean, it's just loads of it. So let's look at the command itself and make sure we haven't completely got that wrong. Well, what we'll do is we'll drop this. And we'll just remind ourselves what that package installs. Just those things. And if we don't install those, we'll then see the impact of that change. So we'll comment that out for the moment. And I'm tempted to start killing this, because it's a bit mental. It's like building spam assassin models and stuff at the moment. Right, I'm just gonna kill this in the background. Let's see now. Let's kill that process there. Is that the right one? So many. It's that one. Okay. Okay. Let's just see what that's done. I think that might have nuked some of it. Let's go back here. Okay, let's go and take a look here. There we go. That killed it. Killed it dead. Right then, let's go back and pick that up from not a crazy place, and we'll save this. And what stage was this? This is the second stage. So we'll not run the bootstrap stage. We'll get in here, and also just to make sure we don't run into a silly problem, we'll just run that stage there. So let's rerun this. This will copy over the bootstrapped stuff from the cache, and then it will pick up that install. So let's just see how this works. So, can you do reverse depends? Yes, we could do that. I just want to watch what's going on here a second and satisfy myself this is the case. But yes, we will do that. That's a good idea. I'm sorry, I'm talking and I'm not being clear why I'm saying these words. So it's only a GNOME says also, can you do apt-r depends? So yes, we will do that. What are you saying here? Let's have a look. Apt install depends. Yeah, I think I'll have that installed. In fact, what's this here? This is Samba. So we're already beyond that line. So we've already got beyond that thing that was installing the whole world. But I am curious to understand what caused that problem. So we're already on to the greeter, and it won't be finished before that stage is complete. So where are we now? So this is installing PipeWire and specifically the Bluetooth codecs. And now, what was this? This is curl, so this is actually doing the setup. There it is. So it's done. So that was the... Oh. Failed. No such... Oh, that's new. Running that. Failed. No such file or directory. What? wget didn't exist. Well, that doesn't make any sense. Should exist. Okay. Well, let's there are strange things occurring here. New strange things that I have not witnessed before. So let's just fix that in the simplest way possible, and we'll come back to figuring out why that is later, because I just want to get this thing built so we can get on and write the drivers. We'll just do that just to be certain. So we'll rerun stage 2 again. So that was a very minimal X, or at least the underpinnings for it. This is pretty much the thin shim of the X server and the mode setting drivers and stuff that we need like that. How very curious. I just want to see that this stage completes successfully, because this is going to be a big problem if we can't get beyond this. I know it was late last night, but this was definitely working last night. So whilst you're doing that, I will bring up this and sudo apt install apt depends. Oh. I think it's like this, isn't it? Let's just do that test. Oh, it's just... Is it that? No. There we go. That completed successfully. Did it actually install? And it did install Ludo. Okay, so that worked. Okay. Well, we're going to push on with the rest of the build. Because I want to get this working. So that's curious in itself. It implies that something else has changed in some of my other stuff. But okay, so we'll get the little desktop on and we'll do this stage at a time to make sure there aren't any other screw ups. So we'll just get this next stage done. So yeah, that's installing the language pack which we've added. This was just so there's an initial language pack to do stuff in English. At some point I may, but the tools exist within that micro desktop to get other languages on the system. That all works rather well. Right, okay, well whilst this is building, let's go and take a look at what we're going to actually be doing, the purpose of this, which was to take a look at this. So this is the DeskPi, so the people that make the case have a GitHub project where they publish, let's call them reference drivers, because as we'll see, it's not like how you'd necessarily do things. So there's effectively two drivers we're going to be looking at here, and they provide implementations in C and Python. And if this were a handheld case, I could be persuaded to use the C versions of the drivers, or at least derive from them, because the C's a bit untidy. Because C is better for battery endurance, and on a handheld battery powered device that makes sense. But I also want other people to be able to contribute to this project, and using Python is much better suited for, you know, getting people involved, particularly for Raspberry Pi projects where Python is kind of the dominant language. So they've got two implementations here, one for the fan controller. I use that process, that name with caution, and here it is, and it connects to the host mode of the daughter board, and that required a configuration change in config.txt, which we'll look at in a moment. It's got this very weird try and then an infinite loop inside it, and I couldn't quite get my head around why this order. It seems to me you'd want the while true, try to open the serial interface, and if not, say, oh, it didn't open, I'll wait a moment and then loop back round again, you know. And so I think maybe we'll change the order of this. And the other thing as well is, instead of using this shelling out to the old video core commands, we'll actually read the temperature off the proc interfaces, and then we'll do something like this in order. We'll re-implement this in order to send the fan speed to the microcontroller over this serial interface. So we'll use this as a basis, and we'll derive from it and hopefully improve it a little bit. But the one I want to write first is this one. And again, I'm a little bit confused at this structuring here, which seems odd, but it's the same idea. You know, it's connecting to the serial interface, and then when that serial interface is available, it sends this power off sequence, and that tells the microcontroller to cut power to the daughter board, which I think will physically turn the device off. So we'll write an implementation of this first, which will be fun to test because it should just cut the power to the Pi, I believe. And then what they've got is some system D units that sit around these in order to control when they're executed. So they've got a system D unit that looks for, you know, the halt and power off and shut down states, and then calls this code. So we'll implement that initially and see how we get on, and that will at least shut the thing down properly, which will be nice. And then there's just that fan controller, and then it may be my casting aspersions on Lurk, we can reintroduce that and get that working as well. So let's see how our build is progressing. So we've got to the end of that next stage there. That's all concluded correctly. So we will now we'll feel confident in the kernel step and the config. So we'll say give us the kernel config, clean it, and produce the image. That should all run to completion, he says. Lurk will be missing. It should install the Python 3 serial stuff that we need. So this should all run. But the purpose here is to get an actual image we can boot on the Pi, and then we can start messing around with this initial, little driver in air quotes. So, Rich Code says, you're in an office building rather than a home office. Yes, I have a home office, and I have this space here, which is some rented space in a local shared office area, and it has air conditioning and things, which is nice. But also it's a nice change of scene, and there's people to have tea and coffee with and chat to during the day, so it's good for staying sane, as particularly coming out of lockdown at the middle of last year, where I was starting to get a bit stir crazy. Hey Big Pod, how you doing? Good morning. Right then, let's start fleshing out some code here. So let's take let's think about this. We'll make a directory. So I've got this idea of splitting the cases into case here. We'll say case DeskPi Pro will create root, and then user local bin, and we'll call this safe. It's not safe. There's nothing safe about it, actually. It's only when you put systemd around it becomes safe. I think we'll just call it power off. It's what it is. So, oh no, it's not going to be called that. We'll just make the directory first, and then we will create a Python script.
Thank you for the follow, JDSPZ.
Thank you very much for the follow, and welcome to the stream. Hey Dust, how you doing? So we'll just call this power off. And I tell you what, for giggle, oops, I've gone the wrong way. For giggles, we will go and get their initial script. Was this the one? Yeah, this was the one. So before we do that, this script, so all of those words are fine. And oops. So user bin env Python 3. We're not going to use time by the looks of it. So we've got this here. So let's first of all do if. Oh, so I've got this Copilot installed, and it started to do these things for me. I know this could potentially be the Python add-on, but Copilot has been making some interesting suggestions. It helped me refactor some code last night, which was interesting. So we'll do this try except here. I think why is it while true? If forever, if that serial port is open, send power off, but then close the serial port. So is it me? Does this seem unnecessary? Copilot. Yeah, so Copilot, it completely passed me by. It's AI assistance. So it's a GitHub AI that you can integrate into your IDEs, and it will give you suggestions. It's like AI pair programming. So I really don't like this here. And also this, except it's just so Dust, I have very minimal exposure with it, but it did help me refactor something yesterday where I'd got repeated code, and I started to not make it repeated, and it suggested the right solution, even with my own variables and things inserted into the code. And I was like, and it was the first time I'd seen a prompt like that in the code editor, and I was like, oh, this is that Copilot thing. And I hit tab and all the code just appeared, and I was like, okay. But then I noticed that my code had a path in it, and it hadn't used the exact same path. So you do have to be aware that it looked correct, but there was one little subtle difference. But nevertheless, it helped refactor 5 lines of code, and I just had to press tab, and I was pretty impressed at how it intuited what my intention was and gave me like the right outcome. Yeah, it's not that I want to become reliant on it, but I was certainly impressed. Hello Yannick, how are you doing? Welcome. I was just talking about Copilot, Yannick. It has already been a help. Yeah. So I'm going to keep this super simple. We're just going to put a try here, like so. Let's just actually see what happens. Like, we do this. Why on keyboard interrupt? Why would the exception be on keyboard interrupt? Because they had a while true, didn't they? Oh, wow, check it out. Here we go. So here's an example of Copilot in action. Can you see that? It has suggested that on this exception, that if the serial port is out, so I'm just going to hit tab. And there we go. Isn't exit sysdot exit though? Is that right? But there we go. That was an example of the sort of thing that Copilot can do. And we'll just try that. Because my feeling is this should either work or it shouldn't, right? I mean, what could be the hold up here? Could this be while no, because we need to. There we go. Well, I think we'll just go with this. I mean, it's going to attempt to create a connection to the serial port. It will then say, if it's open, send that, close, and we're done. And actually, that is always the condition we want at the end. We always want this thing to exit. You don't trust anything AI? Wow. I think those are old ideas we need to get off now. So this script will send power off to the daughter board, and the daughter board will cut the power. So that is what I think we need. I mean, why would I want to put this in an infinite loop? I think we could do something better here to actually make sure we've got a connection here. Nice one, Dust. So Dust says, as soon as GitHub Copilot says, I'm afraid I can't let you do that, Dave, I'm out. Yeah, I thought it was interesting, and because I've got a number of open source projects, it was free to me to enable, so I thought, let's give it a try. You know, what could possibly go wrong? And as you saw, you know, it made a sensible suggestion just then. So, and in fact it made two. It helped me like write some code here without me having to type characters, so that was good. So I think we'll go with that. Let's see how our build is coming along. We should have something out. Yeah, there we go. We've got an image here now. So let's do this thing. Let's put this image on the Raspberry Pi. This does have some case enablement already, as it happens, which I will demonstrate when we get to it. So let's bring up the imager. Is this on the right screen? No, it's not. So we're going to use, I've decided that I'm going to get disciplined about using the Raspberry Pi imager, and we have, here it is, DeskPi Pro Alpha 2, and you can see here that by comparison the Alpha 1 image was 5 gig, and because of the optimizations that I've made in better package selection, it's down to 4 gig. That seems worryingly small. High degree of possibility this won't work at all, so let's see how we get on. So we'll choose the image, we'll tell it to jam it out there and go. So Big Pod says, I don't trust AI as we're trying to create an artificial intelligence, but at the same time I only scratched the surface of understanding. So there's some interesting stuff going on with AI. Like there's a lot of frivolous stuff, but I was watching a research documentary the other day where they've used, they've taken research from some years ago looking at enzymes and bacteria that can break down plastic. And they ran that through many different AI models in order to determine how to improve the efficacy of these bacteria that break down plastic. And they did it with an AI model, and then they only had to test 2 actual derivatives, and they already got a 200% improvement. So this is naturally occurring enzymes that can break down plastic to a point where the byproduct is 94% reusable to recreate plastic with in the future, and the 6% that's lost was a gas that is a byproduct of the enzyme breaking down the plastic. So that's pretty amazing stuff. And also, I've heard about like silicon design. They're now using AI to actually run through different silicon design things to radically improve efficiency. So there's some good stuff happening. It's not all frivolous. Right then, so we've put that on the card. Let's go back here. We'll plug this in. So let's just go onto the capture card. I reckon there's a good chance this isn't going to work because 1 gig smaller seems significantly smaller, and I'm a bit concerned about that. So let's see. Well, it looks like it's going to boot, or at least the bootloader is in the right place. Are we going to get a functioning thing? Okay, well that's good. That means the kernel's come up and it should be doing the file system expand. Oh, nope, it's busted. It's busted. What the heck? Man alive. Okay, let's cheat. Let's cheat. Let's do this based on an image we made yesterday. And we can just focus on the writing the drivers bit, and then I can figure out what I've broken in the build script over the weekend. So we'll take another SD card and we'll put yesterday's build on. So let's go here.
Thank you for the follow, AWR 417H.
Thank you very much for the follow and welcome to the stream. So we'll put yesterday's build on and we'll use that as our starting point. So here it is. Oh no, Alpha 1. There it is. So that was built at 10 o'clock last night. Curious how in 11 hours things have gone so wrong. And that one was meant to be smaller because it is the light derivative. And I've got this one as well. Well, that was from Wednesday, so that's very old. So let's try this one and see what we get. We'll have to... Oh no, this one should enable the USB as well, but if it doesn't, that's a trivial fix we can do, so that's fine. So yeah, BigPod's making some points about like the state of AI, and what I have seen is there's a number of sort of initiatives now within the industry to really start thinking about, you know, what's the governance that needs to be in place around the application of AI and AI/ML and what it's used for and how it's used responsibly. So, nice one. Nocturnal Astro says, sometimes I leave my desk and come back and everything is broken. So 11 hours since so bad. Yes, except I'm confused because 11 hours ago the same build script worked fine and now it's completely busted. So I'm very confused what's occurring there. How did that not bring up? I will figure that one out over the weekend. We should have an image here that works. In fact, we'll just cancel this verification because we don't need it to do that. Continue that. Close that. Yoink this out. Right then. There we go. Let's bring this up. So hopefully this one is a working one I made last night and it should function. I now have to think what changed between 10 and midnight yesterday, and is there anything missing from this that I'm going to assume is there. Oh well, Python 3 serial, for example, so we'll need to install that. Okay, so that's done the file system expansion just there, which is fine. And, oh, okay, so I can see what's busted here. That was a simple thing. That was the incorrect gamma on the splash screen. So actually, we're gonna need to copy over a couple of my, yeah. So it's not going to, yeah. Okay, so it's fine. This is fine. I know where we are. So what we'll do is we'll switch back here. And we'll actually do this. We'll SSH into the device, which should be that. And we'll need to trash the keys because it's a brand new set of keys. So there we go. So we're logged into that Raspberry Pi. So the first thing we'll do is we'll take this script, which is the current version of the session bring up. Let's do this. Oh, hello. Oh, okay. Let's do that a different way. It doesn't like doing that from within inside the code editor. I typed code instead of my password then. Oh, hello. Oh. How did it put in Martin now as well? That's wrong. Oh, that. There we go. Right then, let's get this session stuff fixed. So that's the first fix, and we need to install unclutter fixes. So let's just do that. So we're just going to bring this device up to where I think all of the bits should be in order that we can do the development of this image. So McPhail says, I think we're a very long way from AI crossing a line of no return. Yeah. Yeah, true. Yeah. Yes, it is. I think it is doing that. And actually, if that's the extent of its capability, that's actually extremely useful. Because it may mean that it's just an efficiency of not having to go and look stuff up. If you know enough to express your initial intention, then hopefully it will fill in the blanks without you having to go and look for things. So let's install unclutter xfixes. This unclutter is a thing that removes the mouse cursor from being displayed, and we want to do no install recommends for that. Okay. And now we want to edit the HDMI fixer. That's busted. That's an old version. So let's just delete all of that. Go over here. Pick up a current version. Oops. Right then, let's just reboot the Pi. In fact, actually, let's not do it that way. Let's make sure that this controller works. Yes, so the first thing that it has been done in this case enablement is we have enabled the front USB 2 ports using a bespoke config.txt file. So that now means that we can actually use the controller and do a shutdown of the Pi. I didn't mean to do a shutdown, I meant to do a reboot, but never mind, we get the idea. So we'll power that off and power it back on, and that should boot back into the same session, but we should have none of the bugs. So let's bring that back up. And now we need to install the Python 3 serial stuff, and then we can drop our script in, and hopefully it should just power off the Raspberry Pi. I mean, it's a bit abrupt, but then we'll wrap it in a systemd unit, and I should be able to issue a power down of the Pi. In fact, we can demonstrate something else here as well. There we go. So there's the splash screen is fixed because it's now got the correct gamma. I don't know why the gamma would be non-default in XLI, but there we go. And here we go. So now you can probably see that the that's taking up the full screen rather than that border at the bottom. And what you can't see, but I know, is that this is now running at a full 60 frames per second, not that weird sort of stilted version when it was all a funky resolution and refresh. So this is all working. So what we'll do is we'll just go over here and we will demonstrate that we can SSH. So I'll just clear the screen. I will demonstrate that we can SSH into the device. So here we go. We're logged in. We're logged into our Raspberry Pi. We'll log out again. We will stay on that screen. In fact, we will go back over here, and this is running under the Ludo account, not the root account, which was one of those important fixes. So now I should be able to go in here, turn off SSH in here without being a root user. And now when we come back to here and I try and log in, I can't. So this is working exactly as designed now, or intended rather than the, if I could just press the right button, there we go. And then I can turn that back on. Oops, he says, turn that back on. And we can come back here and we should be able to log back in again. So there we go. That's the security improvements so we can prove that this is the case. So if we do this, we can see that somewhere down here, here's Ludo. This is that front end, and you can see that is running as the Ludo account now, not under a root account. So that's terrific. So that policy kit integration is working a treat. So we do know we're going to need to install Python. Oh, if I could just type today, Python 3 serial. So we're installing that with all of the packages just to make sure that that doesn't put anything weird on, and it doesn't. And whilst we're here, we will also install Lurk just to see what that wants to install, given that I was about to claim that it was doing things it shouldn't have done. That looks fine. So what if we do no install recommends? What's the difference? It's exactly the same. Okay, so that's fine. So we'll install that anyway, because that will enable us to test Lurk as well. I see there's quite the debate going about stuff there. Oh, hey, Takov, you're back. Right then. So let's go and grab our implementation of the first case driver, which was this power off jobby here. And let's assume this is going to work. He says, hopefully. So that is the script. We'll make sure that's correct. So what we'll do now is we will do something a bit different. We're just going to, so this is what it boots into, which is the retro home stuff. Oh, I'm not interested in the right keyboard, am I? So we will turn this keyboard on, which is connected to the Pi, and press escape, and that should drop us out of here back to the display manager. And we'll just quickly, okay, so this has got some of the other changes that I made, so that's fine. So this is the updated display manager configuration, which is all working correctly. We will tell it we want to log into the desktop, and we will log in, and we should get the new desktop. And I'm just doing this just to make sure that yeah, so this has got the new version of the desktop. So we've got no desktop display thing here, we've got no virtual workspaces included in the panel here. we have managing your keyboard, managing your Bluetooth, managing sound, date and time, and session stuff. So this is, you know, the very basics of what you need to get stuff done. And that's the launcher for the game thingy. We've got the browser here. Okay, so that's missing a couple of extra bits that I added, but that's good enough. Okay, so I'll now come back to here. I think what we'll do is we'll log out of the desktop session. And then we'll come back to the code and we'll... There we go. That's all saved. So we're just going to run this and see what happens. At least I'm going to see what happens. I can't show both these things at the same time. So if I run that, it should do nothing. So that did precisely nothing. The Raspberry Pi is still on, as you can see, because we are still connected. So let's go and edit that script and find out what's wrong with that. Oh, hang on. No, it has shut down. It has in fact gone off now. Okay, so I got no indication, but you can see this light here is red, which means it is off. So that did indeed work. So that has powered off the Raspberry Pi. And in fact, what I'll do now is I'll demonstrate that by going back to the capture screen, which says no signal. So we'll push the button and turn the Pi back on. And you can see here that that is now shining blue because it's got power going to the Raspberry Pi. So we should see the Pi boot up. So actually that power off script worked. So now what we'll do is we'll integrate that with a systemd unit file. And that should then enable us to, at the command line, do sudo power off. And the whole device should come down. So, awesome. I wonder what that timeout thing was. I think that's just for establishing the connection, isn't it? So, this should come back into Retro Home. So King Egypt says, did we fix the overzealous install? Yes, we went one step further. We made it so small it didn't boot anymore. So I'm actually using an image I made yesterday in order to get to what I wanted to do, which is develop these drivers. Over the weekend I will fix up whatever bugs I've introduced into the build system. So we'll come back to the code here. We will log back into the Pi. So our script works. Power. That works just fine. We're going to assume that that is now going to work for forevermore and is perfected in every single way. We will now go and look at the systemd unit that they suggest to use, and we'll take a look at that and see if we can improve on it at all. So that should be over here. And if we go to DeskPi, they've got a script for every different platform. Interestingly, they have one for Ubuntu Mate here and Ubuntu. So these, which is the newest one? Manjaro. I wonder if what they've got here. So let's have a look. So this is using the C version, I think. Yeah, the C version. I wonder if any of these are using the Python version. No. Okay, well that's irrelevant. So this is the send the signal to the MCU thing. And where does it send that out to? Echo to safe shutdown daemon. What? Oh, here it is. Okay. libsystemd. Oh, because yeah, okay, because they're combined now. We won't put it in libsystemd. We will put it in root user, like so. And we'll call this DeskPi Pro.
Thank you for the follow, Dodoza_.
Hey Dodoza, welcome to the stream. So let's have a little think here. We'll just call it power off again. Oh, it's not. We need to make that first, and then we'll just go and grab what they suggested, which we'll need to strip out all of the extra craft. Maybe I'll leave that in there for the moment. So we'll get rid of all of that.
Thank you for the follow, noob_of_the_Linux.
Hello, noob of the Linux. Welcome. You're among friends. All of them. There we go.
Thank you for the follow, Namia_1.
Thank you very much, Namia. Welcome to the stream. Let's get rid of all of that crap as well. There we go. So that's the unit file that they suggest. DeskPi Pro. Let's call it what it actually is. There's nothing safe about it. It's power off. Power off. So they say target halt shutdown power off. That seems default dependencies equals no. One shot. Why is it running as sudo? I just run it as a regular user. That's absolutely not required. And our script is called user local bin poweroff.py. Remain after exit. I don't think we need that. I'm not even certain what that means. If anyone does know what that is, let me know. So there we go. Let's do that. Save that. Let's go and copy this. Let's move over here. Oh, I can't call it power off, can I? Let's prefix it DeskPi Pro. That's probably what we're going to need to do to make sure we don't get any namespace collisions. So DeskPi Pro power off. So let's just change that here. File. Save as DeskPi Pro power off service. Save that. And there we go. Let's do that. and then enable this systemd unit. There we go. So I'm going to issue a sudo power off. And that in turn should call this systemd unit, which in turn will call our Python script, which will shut down the MCU and turn all the stuff off. So hey, Tilted, how you doing? Welcome back to the stream. Hello there, Flight Sim Racer, how you doing? Right then, let's try this then. So I've been disconnected and I'm looking at the Raspberry Pi now, which has a blue light on the front, which means it's still got power. And what we're hoping is that that will go red, and there it is. It worked. It has shut itself off. It's actually powered down completely. So that's a win. So let's go back to the code editor and we'll get that integrated into our broken build script. Our broken build scripts. We'll just ignore the fact that things are a bit broken. I think my idea here is you will have seen that I in fact let's just rm that, because we've now got so if I tree case DeskPi Pro root, what I've done here is I'm creating effectively a file system for each case. So what I'm thinking is, in terms of overlaying the case specific configuration, can just copy that stuff over into the built image in order to just simply say, is there a case directory for a root file system overlay? Just recursively copy all of that stuff in. Have a good one, Zeb. Speak to you soon. So, noob of Linux. It looks like you've got relevant information. So it says here, remain off sets a flag that is for systemd services. It tells systemd that the services is still active. If you stop it, it's set to true. Yeah, okay. I got the meaning of what it was for. I was just thinking, why would we require it for this script? Because the script itself is here, which you may not have seen because I don't know if you were here. The script itself is very simple. Attached to the serial interface, if the serial interface is open, send the power off sequence to the MCU, close the interface, exit. So my script itself doesn't want to hang around. It wants to be done. So I think that was a leftover from the script that they created, which was wrapped inside an infinite loop, which I couldn't understand the purpose of, so I removed. I'd be interested to know what this is. Default dependencies, no. But anyway, we're in a good shape there. So this is that, and what we need to do now is 755 to root case DeskPi root user local bin power off. There we go. So that if we now look at that file system, so there's our case file system, and I think we could probably have a bash at the other one. So let's go back to their scripts here. So first of all, we'll take this remain after exit. So that's fine. So this one's going to work in a slightly different way. So let's go in and create this one. Say file new, paste that in. We're going to get rid of all of that stuff. Oh, it's now called DeskPi. That one needs a terrible variable names that they've used, but we'll get rid of all of that stuff anyway. And then we'll have echo. We don't need that at the front, so we'll just get rid of all of those. There we go. Get rid of that. So there's our units. It's a one-shot. We're not going to need sudo. We're going to call this user local bin, and we'll call it. Okay. They background it. I'm not sure you need to do that, do you? So we will call this DeskPi Pro fan control .py. DeskPi Pro PWM fan control service. Okay, multi-user target seems reasonable. Hang on a minute. Oh, file. I've done this mistake before. Right. Get rid of that file. Save as. Why does that pop out in the background? I need to figure that out. That's annoying. Is that... So, DeskPi fan control. We just call it fan control seems reasonable. I'm trying to think of the other cases that we need to support in the future. They all have some common facilities. It'll be good to get some sensible names in place. What? Why didn't that work? There we go. Right then. So now we'll need to sudo. So case DeskPi and user local bin, and we'll just call this one fan control. Yes, like so. It's only the systemd units we need to namespace. So we'll call that fan control. And we will copy over their script initially, and then we'll go and see what we can do to maybe improve upon it. So drivers, we'll use the Python version again. They've got one here called PWM control the fan. We will just take that as is, and now we'll think about how we improve it. So the first thing we'll do is put a shebang in. We don't need any of those comments in there. We don't need time. We won't need sub process because we're going to do this differently. And here's this infinite loop, which we do need in this one. This one makes sense to have an infinite loop. I think the loop needs to be outside of the try, but okay. And we're going to replace that with something else we made notes about somewhere in one of these. Was it here? Build the image. I definitely made notes in here about reading the temperatures. At least I hope I did. Oh, it's up here in a different section, isn't it? Here we go. We found a little bit of Python that we're going to reuse here. So let's go to fan control. We'll do that. We'll lob in our function here. Oops. So that's something to read the temperature. And we need to get the serial controller again. And then I think we need an infinite loop. And surely we want that like so. So loop infinitely. Try to establish a connection to the controller. If it's open, CPU temp will now be equal to get CPU temperature. Don't need that. And they've got some boilerplate here for what they think the fan speed should be. So if it's open, then do those things. If we get a keyboard interrupt, okay, set the fan to 0, okay, and close the serial connection. Okay, let's have a look here. So McPhail's got some comments. McPhail says, I don't know much about System D. Why after equals? Won't that keep the fans spinning? Annoying System D. So let me just go and look at the fan control service. So after, are you talking about this here, after multi-user target, McPhail? Is that what your question is referring to? I'm going to assume it is. Okay, so this tells this System D unit what phase of the computer life cycle this should be run. So once multi-user state has been reached, this service will run. So this will then execute this bit of Python. And this bit of Python will then change the fan speed based on the temperature of the CPU until the device gets powered off, because that power off script that we've just done, that sends a power off signal to the MCU, which also controls the fan. So when the device is shut down, the fan should go to nothing. But I'm thinking we should probably take this line here and put it in our power off service here. So I think we should say spin the fans down and then power off the device in the power off thing, right? I don't think we should be changing the fan speed you know, on this code here based on exiting, right? What do we think about that? So let me just have a little look here. So there were some follow-up questions. So Noob of the Linux says, is this a replacement for sensors, or will it be running alongside of it? What do you mean by a replacement of sensors? So this DeskPi Pro case has a daughter board with a microcontroller in it, and what this is doing is it's a bespoke interface to that daughter board in order to control the things that are connected to that daughter board, which is power and the fan speed. So this is not regular Linux LM sensors or anything like that. So King Egypt says, do you need to throttle that loop so it doesn't consume performance? Yes, you absolutely do want to throttle that. So I don't think you want to be constantly reading off the speed and potentially changing the fan. I think we can sleep in here somewhere for a period of time, probably every couple of seconds. So yeah, I agree. Good catch. And then McPhail says, isn't multi-user quite late in boot though? I hate fans blowing off the dust before the fan control service kicks in. So the default for the fan in this is to be disabled. So when you turn the... I've never had the fans run in this because this is the first time I'm implementing the fan controller. I've had these sat on my desk for months. So power comes on, the fans are off, you get to multi-user, and then the fan control service will kick in, and then it will moderate the fan speed based on temps. No problem, McPhail. Rev for the fan. Right, so what are we looking at here? That all looks fine. I think we want to have this sleep here for 2 seconds maybe. What was that telling me? It was giving me options. Okay. So also, what's the... Is it finally? Isn't it accept and... Okay. Are we back again? Is this me streaming? That was OBS crashing. That was OBS crashing. And I've just very quickly restarted OBS and hit all of the buttons. So, I'm just going to take a moment. Hopefully stream protection kicked in. This has come back on the same stream. And you're all still here. And you can still hear me and see me. Okay. That was alarming. That's... Seems Fridays are what's the word? Haunted, because that happened the other day as well. Right then. Hopefully, okay. We're all back. Hello. Sorry about that. Sorry for the interruption. That was unexpected. So, yeah, we can do a finally, right? We should. Ah, here we go. This is better. Cool. So this again, that was Copilot making recommendations there, which I agree with. So let's think. That is just going to loop round and do this thing. So what do we think about these options? If the temperature is less than 40 degrees, the fan speed should be 0. That seems fine. If the temperature is between 40 and 50 degrees, the fan speed should be 25%. If it's between 50 and 75, it should be 50. Oof, okay, well, we'll just go with that as an example. So, how am I going to know? I can't... what do we think? That looks sensible, doesn't it? So we should probably do something here, which is just to see what's going on. There we go. And we should probably replace all of this here with just some code that actually sets a variable to the appropriate PWM and then just has a standard thing. So I think we'll massage that in time, but let's just copy this over and run it on the Pi itself and see what happens. So I see there's some comments and what have you. Let me just go and see what we get here. So So still alive, yeah. Yeah, that was exciting. So Big Pod says that's the annoying part of Twitch. If you're offline for a bit too long, it starts a new stream. So they do have a facility called Stream Protection, which is off by default, but if you turn that on, it gives you a grace period where they detect you've gone, they insert a stream fail piece, and then you can come back. But as that went down, I was thinking, oh god, is this my PC rebooting again? Because we've had power problems here yesterday, which is why today's stream with work, yesterday's stream with work is going to be today, because the power was problematic. So let's just copy all of this stuff and go over to our Pi here. Oh, which is on. So we'll turn the Raspberry Pi back on. So let's just watch that boot up so we know that's come up properly. Thank you, King Egypt, for the peer review on my janky bit of code. That's what makes it readable, Big Pod, all that white space in the Python stuff. Hey, Takoff, how you doing? So we're just going to test another little driver. This is the fan control for this device. I'm really not going to know. I mean, it's really very cool to the touch, and I know the fan isn't spinning at the moment. So the device is back up. Let's log in. Fancontrol.py is what we're going to call it. We'll paste in what we've just been working on. There it is. From time import slip. Oh, did you see that? I didn't type that. That Copilot did that. That's pretty cool. So when I typed in sleep here, it knew I hadn't done the import, and it did that at the top. That's pretty slick. That is pretty slick. I like that. There we go. That's so. Thank you, Yannick, for that tip about Copilot. So far, it's working for me. It's not tripped me up yet. It's only. No, I pasted. So what I'm doing, Big Pod, is I'm editing in my IDE here, and then I'm just simply copy and pasting to drop it into the Pi via a SSH session. So we'll just. I'm not sure it is Yannick. I think it's Copilot that's doing that, because I've been using the Python extension forever. But you're saying that automatically adding the imports is VS Code's Python plugin. Okay, yeah, I stand corrected, in which case. It was definitely Copilot that helped me refactor a shell script, though. It's not Copilot. Oh, okay, I'm giving it too much credit by the sounds of it. Okay, so let's just run this here and see what happens. Well, there we go. Oop, sys is not defined. I don't need to change, I just need to correct it here. Okay, so it runs once. Why does it only run once? Oh, because I've got a finally. I don't want that, do I? I want a... There isn't a final conclusion to this. Only in the event of me exiting. So let's run that again. So this is getting the speed, and we're currently just hovering around 40 degrees, which is the point at which it says the fan should be on. And I think 1 second is 2 seconds. That's too frequent. I think maybe we can do 5 second intervals. I think that will be more than enough. So we could do this. We could create a new variable called fan speed. PWM actually. No, let's call it fan speed. Fan speed is that. And then we'll have a statement that does something like this, which is in fact, why am I doing this like an animal? So import sys, that was the first thing we need to do, wasn't it? And we don't want this finally piece, but we do want that sys exit up here. And then we'll change this to be we'll just put all of these in place. 75 and 100. I don't think we're going to want that going to 75 or whatever. We'll then pull that back here. Thank you very much for the sub, King Egypt. I appreciate that. So PWM speed equals PWM. Did you see that? So what's suggesting that bit of code? Is that the Python plugin? Or is that Copilot? Did you see what that just suggested? Oh, I can't do this, can I? Trying to be too clever for my own good. Okay. Let's just leave all that alone then. We don't need that much sophistication. Okay, we'll just leave that alone. That's Copilot. Okay, so I am observing Copilot doing some stuff then. I'm just getting confused with what Copilot's doing versus some of the others. So what we'll do is we'll set this fan speed to, if it's less than 40, let's really go for it. So I want to hear this thing, right? So less than 40, we'll set it to 80. And we'll set this to 95, just so I can hopefully hear the effect of doing this. So let's go over here. Yes. I think I can hear the fan spinning up. It's not very loud. But there we go. I wonder if I could I Control C. And do that. That's definitely working. Okay. Okay, that's definitely doing its thing. Right then, so let's just look at some of the comments, because I think we've got a solution there. So okay. Well, King Egypt says, back in my day we used Turbo Pascal and MS-DOS. Slept in a shed. Still ask for more. I used to love Turbo Pascal. Used to love Turbo Pascal. All my stuff is in weird places though because of that OBS crash. So yeah, Takov, I think we've got the first bits in place there for those two drivers. So that is what I intended to get done. We'll now just have to go and unbreak the build system because the image builds are completely on the floor, and I'll have to figure that out. Isn't there any feedback on the serial? Possibly. I haven't seen that documented yet, so I'll have to poke around at that and see if we can read off the serial, but I don't know. Possibly not. It might be a trust system. Turbo Pascal. Well, Pascal generally is. I loved Pascal. I went from 6502 assembly to Pascal, and obviously that felt like the future. And then from Pascal to well, curiously modular 2, because they're basically the same, and then C. Right, okay, this is good. So let's go back and take a look here. We have got, oh, that doesn't need to be 2 seconds though. We can definitely do that every 5 seconds. And we'll change that to 0 and that to 25. We don't need to print that. We should probably do something, shouldn't we, in here? We should probably fancy this up a little bit, but for the purposes of what we've got here, this is fine. Okay. Yeah, I wonder what we can do. Wonder what we can read. I'll just have to sort of read off it randomly and see what we get. So what do we got here? We've got some feedback. Mini Roach says, need edge cases when the temp is exactly 40 and 50 and so on. Yeah, you're right. Actually, it's not coarse enough, is it? So that should be. Oh, it's probably close enough, isn't it? I mean, that could be 49, for example, and that could be 64, and that could be 74. How do we like that? But yeah, that tabling could probably be better defined. I mean, what would be fun is just make it linear. Just say set the fan speed to the CPU temperature. Yeah. So that should be. Yeah, you're right. Less than or equal to, greater than or equal to. less than or equal to 50, greater than or equal to 50. Oops. There we go. How do you like that, Mini Roach? Are we happy with that? Does that yeah, so yeah. Is that a bit more comprehensive now? Okay. I mean, I'm not sure whether these are the correct numbers. It seems 25% when you get to 40 degrees is probably a little bit much. So I'm thinking we'll actually do this one, so less than 44. Because 44 degrees is really nothing. And we'll make that one 45. And then, there we go. And then 50 degrees, that probably doesn't need to be 50. That could probably be 40%. And then when you get to 65 to 70, yeah, 75. And I would say this one, you probably only want at 80, so make that 79. Something like that. That's a slightly more, you know, what a fan curve would look like in a PC case. And this is probably where you're going to see it, you know, if you stress it. That's probably where it's going to sit, something like that. What do you reckon, Mini Roach? Do you reckon that's a better distribution there? We'll leave that in, because if you do want to run it. Maybe do less than 50 instead of less than 49. Like so. Yep, okay. There we go. How are we looking now? I like this feedback, by the way. I did think about like the inclusion of these things. So less than 44, greater than or equal to 45. In fact, we're going to need to round this, aren't we? Because at the moment that's printing a float. Oh yeah, that's not a bad idea. Yeah, King Egypt makes a good point. You could do it the other way, which is do it reductively. So start with your hottest, so it just needs to be if the temperature is greater than a particular thing. That's actually a really good idea. I like that. That's good. Yeah, in fact, look, that's exactly what it was about to. Did you see that? How do I actually get that? I want to accept that. How do I do it? That is Copilot. Accept. There we go. Wow, check it out. It's getting a bit ahead of itself there. So we'll have 80 like so. So if the CPU temp is greater than it did just make another suggestion there, but it went away. We don't want that. So yeah, and then we can have LF CPU temp, yeah, greater than, well, in this case it's going to be 65. Yeah. Greater than 65. Then we'll take this here. And then we'll have a final else, which is going to be set the fan to 0. Yeah, it is a good suggestion, King Egypt. So what was our next? It was actually 50, and it was that. And then we'll have, if the temps are greater than 40, blah, we'll make that 45 though. And then we'll grab our PWM 25 there, lob that in there. There we go. So now we can chuck all of this away. There we go. That's a little clearer as what's going on as well. That was a quality suggestion, King Egypt. Well done. There we go. And that's missing. Surprised that wasn't being flagged. Okay, so greater than 80 degrees, we're going to have all the beans. Greater than 65, we're going to have a 75% fan profile. Greater than 50 degrees, we're going to have 40% on the fan. More than 45, we're going to have 25%, and anything else, we're just going to shut it down. There we go. Yeah, nice one. That was a great suggestion. Really good. See? See? Pair programming via the internet's great. Okay, I'm happy with that. I think what we'll do is we will head over to this screen here. We will hit that button there. What's this? Last stream. Okay. Well, maybe we'll drop in there because they're usually good value. Those. Just seeing what else is going on Twitch, but I think I've made my decision where we're going to go. So let's hang on a minute. Okay, good. Right, I'm just finding where we're going to go. Where we're going to go raiding, and I have found our where we're going to go with that. Let's do that. Right then, let's drop in here. So I will need to get all of that stuff committed up. Thank you all very much for coming. Thank you for the great suggestions. I'm surprised my lights are still working. All of you have a fabulous weekend. I hope the weather is good again. I will tinker with this stuff in the evenings over the weekend, and I think on Monday we'll probably continue with Retro Home, but if we don't, we may drop into QMU and DebGet. But we will definitely be doing Retro Home at least twice next week, maybe on Monday. But I hope you have a fab time. Thank you for coming. Thank you for the great suggestions. Thank you for the help. And we're going to go raiding now. We're going to go and see White Panther. They're usually doing interesting web dev stuff, and quite often they are, yes, we're changing channels, and quite often they are doing integration with OBS using JavaScript APIs and what have you. So let's go and see what they're up to. Have a great weekend. See you soon. Bye for now. Bye.